This is SpaceTime, Series 20, Episode 21. SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe. You can download SpaceTime as a free twice-weekly podcast just about everywhere, including iTunes, Stitcher, Pocket Casts, Bytes.com, YouTube, SoundCloud, Audio Boom, and from spacetimewithstuartgary.com. The show's also broadcast coast to coast across the United States on Science 360 Radio by the National Science Foundation in Washington, D.C. Coming up on SpaceTime, new clues about the universe's first stars, NASA's new mission to Jupiter's ice moon Europa, and the perfect storm of fire and ice which may have led to Snowball Earth. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Astronomers studying a distant galaxy have discovered some new clues about the very first stars to shine in the universe. The research team were observing a young remote galaxy called A2744 YD4, located a staggering 13.2 billion light-years away. To put it another way, this ancient galaxy was being seen when the 13.8 billion-year-old universe was just 600 million years old. That's a period when the very first stars and galaxies were only just beginning to form. In fact, the time corresponds to what astronomers refer to as a redshift of Z equals 8.37. That's smack bang in the epoch of reionization, when the very first stars in the universe began to shine. The most surprising feature of this youthful galaxy is that it already contained an abundance of interstellar dust, the debris created out of the supernova deaths of an earlier generation of stars. The study's lead author, Nicholas Laporte from University College London, says A2744 YD4 isn't only one of the most distant galaxies ever observed, but the detection of so much dust means early supernovae had already polluted this galaxy. Cosmic dust is mainly composed of silicon, carbon and aluminum, in grains just a millionth of a centimetre across. The chemical elements in these grains were forged inside stars. They're then scattered across the cosmos when these stars die in powerful supernovae, the final fate of all short-lived massive stars. Today, all this cosmic dust is fairly plentiful across the universe. It's important because it's a key building block in the formation of new stars, planets and complex molecules. But back in the very early universe, before the first generations of stars died out, cosmic dust was extremely scarce. In fact, those very first generations of stars, population 3 stars as they're called, didn't have any cosmic dust to form out of. Consequently, they were created out of almost pure hydrogen and helium, with only a smattering of lithium and beryllium. This discovery was made using the European Southern Observatory's Atacama Large Millimetre Submillimetre Array Telescope, ALMA, located high in the Chilean Andes. The observations of this ancient primordial galaxy were only possible because A2744 YD4 lies directly behind a nearer massive galaxy cluster called Abell 2744. Abell 2744 is a huge object lying some 3.5 billion light-years away, and it's thought to be the result of 4 smaller galaxy clusters colliding. It's been nicknamed Pandora's cluster because of the many strange and different phenomena that were unleashed by the huge collision, which occurred over a period of about 350 million years. Mind you, the galaxies only make up about 5% of the cluster's total mass. Another 20% is hot ionized gas and plasma, and the remaining 75% is that mysterious substance known as dark matter. In fact, it was this dark matter component in Pandora's cluster which provided the massive gravitational lensing effect needed to bend and magnify the light from the far more distant background galaxy A2744 YD4. Acting like a giant cosmic telescope, gravitational lensing, which was first postulated by Albert Einstein in his theory of general relativity, magnified the more distant A2744 YD4 by about 1.8 times. Allowing the authors to peer far back into the early universe. The ALMA observations also detected glowing emissions for ionized oxygen from this distant galaxy, and that makes it the most distant and hence earliest detection of oxygen in the universe ever made. This detection of dust in the early universe provides new information on when the first supernovae exploded, and hence the time when the very first stars bathed the universe in light. Determining the time of this cosmic dawn has been one of the holy grails of modern astronomy, and it can be indirectly probed through the study of early interstellar dust. The team estimates that A2744YD4 contains an amount of dust equal to about 6 million times the mass of our Sun, while the galaxy's total stellar mass, that's the mass of all its stars, is equivalent to about 2 billion times the Sun's mass. The authors were also able to measure the rate of star formation in A2744YD4, finding that it was producing about 20 solar masses a year. Now that compares with today's Milky Way galaxy, which is producing about 1 solar mass per year. The stellar formation rate for these very early massive but short-lived first-generation stars means the huge amounts of cosmic dust seen in A2744YD4 was probably formed in just 200 million years. And that places the very first stars at just 400 million years after the Big Bang. Now, 13.4 billion years later, our Sun, the Earth, and for that matter human life, are all the products of that very first generation of stars. So by studying their formation, lives and deaths, astronomers are really exploring our own origins. This is SpaceTime. I'm Stuart Gary. NASA has formally named its next mission to the Jovian ice moon of Europa the Europa Clipper. The mission is slated to launch around 2022. Europa Clipper will explore this frozen world containing a deep liquid water subsurface global ocean, which has made it a high priority for scientists. The mission will investigate the habitability of the 3,122 kilometre wide ice moon, which possesses all three of the ingredients necessary for life: liquid water, chemical nutrients, and an energy source sufficient to enable biology. In a way, this is a follow-up to the observations made by NASA's Galileo spacecraft during its 8-year study of the Jovian system, which first indicated the existence of a subsurface ocean beneath Europa. Europa is thought to have a small iron-nickel core covered by a silicate mantle. The mantle is in turn surrounded by this deep, global, salty liquid water ocean, which in turn is covered by a 100-kilometre thick crust of ice. Astronomers have also determined that this moon, which is only slightly smaller than Earth's moon, has a tenuous atmosphere composed primarily of oxygen. Europa has the smoothest surface of any known solid object in the solar system. Its surface is striated by cracks and streaks, and there are very few craters, indicating a young crust which is continually being resurfaced. Scientists think that's caused by water from the subsurface ocean seeping up through the cracks and relayering the surface. Astronomers believe gravitational tidal flexing caused by Europa's orbit around Jupiter is generating internal heat through friction, keeping the oceans liquid and driving surface ice movements similar to plate tectonics here on Earth. Images from the Hubble Space Telescope have captured water vapour plumes erupting into the skies of Europa, similar to the cryogeysers seen on Saturn's ice moon Enceladus. Interaction between the rocky mantle and the ocean, and between the ocean and cracks in the icy surface crust, allows the mixing of chemicals into the ocean. And for scientists that's intriguing, because that's the sort of chemical soup which raises the possibility of life. And finding life in the oceans of Europa would be terribly important, and not just for the obvious reason of finding life. You see, because Mars and the Earth have been swapping rocks literally for 4.6 billion years, the possibility of discovering evidence for past or present life on Mars, while it would be a stunning discovery, wouldn't really be all that unexpected. And that's not meant to downplay the importance of such a discovery. However, because of the far greater distance of the Jovian system, it's unlikely that the Earth, or Mars for that matter, would have swapped rocks with Europa. Therefore, any detection of life in the oceans of Europa, or further afield in the subsurface oceans of, say, the Saturnian moon Enceladus, would mean that life is likely to be common throughout the universe. Either way, if life is common in the universe, or if it turns out Earth really is the only place where life has ever evolved, either result would be the most important scientific discovery ever made. According to NASA, the name Europa Clipper harkens back to the clipper ships that sailed across the oceans of the Earth in the 19th century. Clipper ships were streamlined, three-masted sailing vessels renowned for their grace and speed. These ships rapidly shuttle trade across the oceans and around the globe. And in the grand tradition of these classic ships, the Europa Clipper spacecraft would swoop past Europa on an orbital shuttle every 2 weeks or so, providing heaps of opportunities to study the Moon close up. The prime mission plan includes around 45 flybys of Europa at altitudes ranging from 2,700 kilometres down to just 25 kilometres. During these flybys, the spacecraft would image the Moon's icy surface at high resolution, investigate its composition and the structure of its interior and icy shell. The spacecraft will orbit Jupiter rather than Europa in order to keep the probe out of Jupiter's challenging radiation zone as much as possible. Each flyby would cover a different sector of Europa in order to achieve a medium-quality global topographic survey including ice thickness covering at least 95% of the surface. The probe could fly at low altitude through the plumes of water vapour erupting from the Moon's icy crust, thus allowing it to sample Europa's subsurface ocean without having to land on the surface and drill through 100 kilometres of ice. Although early proposals for the Europa Clipper did include a small lander, it now seems likely that a separate standalone lander mission will be developed. Early plans for Europa Clipper were designed around launching on an Atlas V rocket. But that's now been changed to NASA's new Space Launch System heavy lift rocket, the SLS. This is Space Time. I'm Stuart Gary. A new study claims a perfect storm of fire and ice may have led to Snowball Earth, the largest glaciation event in our planet's history. Geologists and climate scientists have been searching for the answer to Snowball Earth for years, but the root cause to the phenomenon remains elusive. Now a report in the journal Geophysical Research Letters has come up with a new hypothesis about what caused the runaway glaciation, which covered the Earth in ice, possibly from pole to pole. Researchers have pinpointed the start of what's known as the Satean Snowball Earth event, which occurred about 717 million years ago. It was around the same time that a massive volcanic event devastated a huge area from present-day Alaska all the way to Greenland. The study's authors, Harvard University professors Francis MacDonald and Robin Wordsworth, say this is no coincidence. It's well known that volcanic activity can have a major effect on the environment. So MacDonald says the big question is, how do these two events relate to each other? At first, MacDonald's team thought that basaltic rock, which breaks down into magnesium and calcium, would have interacted with carbon dioxide in the atmosphere to cause the cooling. The problem is, if that was the case, the cooling would have taken place over millions and millions of years. And the thing is, radioisotopic dating from volcanic rocks in Arctic Canada are suggesting a far more precise coincidence with cooling. MacDonald therefore turned to Wordsworth, who models climates on non-Earth planets, and asked if aerosols emitted from these volcanoes could have rapidly cooled the Earth. Wordsworth's response was yes, under the right conditions. Wordsworth points out that it's not unique to have large volcanic provinces erupting. These types of eruptions have happened repeatedly through geological time, such as the Deccan and Siberian traps. But the thing is, they're not always associated with cooling events. So the question is, what made this event different? Geological and chemical studies of this region, known as the Franklin Large Igneous Province, showed that the volcanic rocks were erupting through sulfur-rich sediments. Now, these sediments would have been pushed into the atmosphere as sulfur dioxide during these eruptions. And the thing is, when sulfur dioxide gets in the upper layers of the atmosphere, it can block solar radiation. A recent example of that was the 1991 eruption of Mount Pinatubo in the Philippines. It shot about 10 million metric tons of sulfur into the air, and that reduced global temperatures for a year by over a degree. And it doesn't end there. You see, sulfur dioxide's most effective at blocking solar radiation if it gets past the tropopause. That's the boundary separating the troposphere where we live and the next atmospheric layer known as the stratosphere. If it reaches this height, it's less likely to fall back to Earth in precipitation or mixed with other particles. It therefore extends its presence in the atmosphere from just a week to around a year. And the height of the tropopause barrier all depends on the background climate of the planet. The cooler the planet, the lower the tropopause. In the case of Earth, there are periods in our planet's history when it was very warm, therefore volcanic cooling would not have been very important because the Earth would have been shielded by this warm high tropopause. However, in cooler conditions, the Earth becomes uniquely vulnerable to having these kinds of volcanic perturbations to climate. McDonald says the models show that context and background really do matter. Another important aspect is exactly where the sulfur dioxide plumes reach the stratosphere. Due to continental drift 717 million years ago, the Franklin Large Igneous Province where these eruptions took place was actually situated near the equator, which of course is the entry point for most of the solar radiation keeping the Earth warm. Now all this means this light-reflecting gas entered the atmosphere at just the right location and altitude to cause cooling. But yet another element was still needed to form the perfect storm scenario. After all, the Pinatubo eruption had similar qualities, but its cooling effect only lasted a year. The eruptions throwing sulfur in the air 717 million years ago were not one-off explosions of single volcanoes like Pinatubo. The volcanoes in question spanned almost 3,000 kilometres across Canada and Greenland. So instead of singularly explosive eruptions like Pinatubo, these volcanoes were erupting continuously, sort of like those in Hawaii and Iceland today. The researchers demonstrated that a decade or so of continual eruptions from these types of volcanoes could have put enough aerosols into the atmosphere to rapidly destabilise the climate. And cooling from aerosols doesn't have to freeze the entire planet. All it has to do is drive the ice to a critical latitude and then the ice does the rest. The more ice, the more sunlight is reflected and the cooler the planet becomes. It's a feedback loop. Once the ice reaches latitudes around present-day Sydney or Los Angeles, the positive feedback loop takes over and the runaway snowball effect is pretty much unstoppable. Understanding how these dramatic changes occur could help researchers better understand how extinctions occurred, how proposed geoengineering approaches may impact climate, and how climates change on other planets. Wordsworth says the research shows that scientists need to get away from a simple paradigm for exoplanets, only looking for stable equilibrium conditions and habitable zones. This study shows that the Earth is a dynamic and active planet which has had sharp transitions. And Wordsworth says there's every reason to believe that rapid climate transitions of this type are the norm on planets rather than the exceptions. I'm Stuart Gary. This is SpaceTime. The March issue of Australian Sky and Telescope magazine has hit the newsstands. And joining us now with the details is the magazine's editor, Jonathan Nally.
Our cover story this month, Stuart, in Australian Sky and Telescope is The Secrets of Super Earths. It seems our galaxy is teeming with the sort of planets that aren't found in our solar system and were once thought impossible. And these are the ones that astronomers called super Earth.
What's the definition of a super Earth?
Well, not everyone agrees on what the exact definition of a super Earth is, but roughly speaking, it's a planet that's between about 1.5 to 2.5 times as big as the Earth and 5 to 10 times the mass of the Earth. So they're two different things, size and mass. So 1.5 to 2.5 times physically as big and 5 to 10 times as much mass. Now, in our solar system, we have 3 classes of planets. The small rocky planets of the inner solar system, and Earth's one of those, and the others are Mercury, Venus, and Mars. In the middle, you've got the 2 gas giants, Jupiter and Saturn, and the next 2 out are Uranus and Neptune. They used to be called gas giants. These days, they call them ice giants. Neptune, for instance, is about 4 times wider than the Earth, but it's 17 times more massive, has a deep, thick atmosphere. And many scientists thought that any planets out there in other star systems that, when they formed, were only a little bit bigger than Earth, would end up gathering lots of gas onto themselves and would end up like Neptune. In other words, out there they thought you'd find Earth-sized planets and Neptune-sized planets and nothing much in between, basically. Well, now we know that's not the case. There are plenty of in-between planets out there, and these are the ones they're calling super-Earths. And they're finding some really odd ones, too. I'll just give you one example. There's a planet 40 light-years away called 55 Cancri E, which is about twice as big as the Earth. Now, they're able to tell that it has one side facing its star all the time and one side looking away. It's tidally locked, they call it.
Like the moon.
Like the moon's always got one face, towards us. So this planet is tidally locked towards its star, so one side's always facing its sun and the other side's facing away. So one side's going to be hotter and the other cooler. Now, the scientists thought that the hot side would produce strong winds because it's been heated up that would carry some of that heat back around to the cooler side, and the heat would sort of more or less get evenly distributed that way through sort of atmospheric weather patterns. But when they took a close look at the data, they found that that wasn't the case at all. One side is boiling hot and the other side is cold. And so what that tells them is there isn't an atmosphere to redistribute the heat around. And also it means that given the temperatures, the hot side would be boiling and bubbling with lava. Not a nice place at all. So that's our cover story this month in Australian Sky and Telescope, The Secrets of Super Earths. Now, a couple of really good stories we have. Well, one for beginner astronomers and one for all astronomers, I suppose, or amateur astronomers. The first one is we take a look at how you can take some fantastic images of the planets of our solar system using inexpensive video cameras. Now, people have got little cameras in their phones these days, and you've got little pocket cameras, and you've got digital SLRs, that kind of thing, but you can also get video cameras. And people first started using webcams for this work, but you can get better ones now. And what video cameras are good for is because they take lots of frames per second. And what this does, when you go back and look through all these frames that you've taken, you can get the ones that are really good because you can catch moments of what astronomers call good seeing. That's when the atmosphere is nice and steady and you're not getting so much blurring, when the blurring's at a minimum. So this article gives you lots of tips and hints of which cameras to try, which telescopes to use them with, and what sort of software you need to dig into all the images and pick the good ones and that sort of thing.
Do you still have problems with the Earth's rotation and you have to compensate for that?
No, not for these sort of ones. If you're doing hours-long exposures like people used to do with film cameras in the old days, then yeah, you would have to, because the image that you're looking at rotates. It's hard to explain over the radio, but it does rotate from one side to the other side. With these sort of snapshot-type cameras, no, you don't get any problem with rotation at all. So yeah, you can get software comes with most of these cameras, but you can also get lots of free software off the internet. People have written lots of good programs that you can use to pick the best pictures and stack pictures together to get a better result and all sorts of things. Now, the other really good article we have, which is good for beginners and experienced amateur astronomers alike, is how to look after your lenses and eyepieces. This is really important. I mean, some of this gear is quite expensive and you want to take good care of it. And this applies to binoculars and telescopes and anything that's got lenses in it. So we've got one of Australia's optics experts, Roger Davis, to give us his top tips for keeping optical surfaces clean and in good shape. Roger actually runs a business and has done for years that does exactly this for people. They send their telescopes and binoculars and things to him when they've gone too far, haven't been clean for a while, and he gets them all nice and spick and span again. So he's seen everything. He's seen everything that people have done to their astronomical gear, from just normal dust build-up to people who've tried to do their own repairs and things or cleaned inside their telescopes and have got it completely wrong, and they've called out, "Help, Roger, help me fix this, would you?" And he gets stuff sent to him from all over the place. So yeah, we got Roger to write us a great article on how to keep your lenses and eyepieces and that sort of thing clean. I actually learned quite a lot from it. And it doesn't take a lot of effort, doesn't take expensive stuff. It's really just a lot of common sense. So yeah, that's one worth reading, Stuart.
That's Jonathan Nally, editor of Australian Sky and Telescope magazine. And that's the show for now. You can subscribe and download SpaceTime as a free twice-weekly podcast through iTunes, Stitcher, Bytes.com, Pocket Casts, SoundCloud, YouTube, Audio Boom, and from SpaceTimeWithStuartGary.com. The show's also broadcast coast to coast across the United States on Science 360 Radio by the National Science Foundation in Washington, D.C.
This is Spacetime with Stuart Gary. For more, you can follow us on Facebook, Twitter, and Tumblr. Just search for Spacetime with Stuart Gary.
Spacetime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.